two conducting spheres each have a net charge of 5.0 millicoulombs and negative 9.0 millicoulombs and attract each other with a force of 4.05 times 10 to the third newtons. The spheres are brought into contact and then moved apart to the initial distance. What is the new force between the spheres? Is the force attractive or repulsive? This is a several-part problem. So first of all, let's find out how far these spheres were apart. We start with Coulomb's law, and we need to solve for r sub 1, 2. So we bring that up here to the left side, divide by the force, and take the square root. So again, try and do that in your head. We then plug in the numbers, and we put in absolute values here for the charges, so we will get a positive value of the distance, and we find that the distance between these two spheres is 10 meters. And we're going to return them to 10 meters when we're done with the problem. So now we're ready for part 2. And let's just erase this circle, we're not going to need that. Now part 2. We have to find what charge is on both spheres after they touch. Well, the way to do that is we add up the initial charge. So our original charge is a negative 4 millicoulombs. Our final charge on each object will be the same. They'll share the charge. So that'll be your initial net charge, which is negative 4 millicoulombs divided by 2. So each object will now be charged at negative 2 millicoulombs. To find the force, we go back into Coulomb's law. We substitute in the values for the different numbers. We found the charge. Each one is the same, negative 2 times 10 to the minus 3 coulombs. We found 10 meters from the answer to part 1. And we find a force of 360 newtons. And it will be repulsive because both charges have the same sign.